Okay, good morning, students. Welcome to today's lecture on ICT. So, we were talking about the fertilizer industry, which is in the third chapter. And after discussing the nitrogen industry, in nitrogen industry, we have seen synthetic ammonia, nitric acid, urea, then other nitrogenous fertilizers. So, these were discussed in nitrogen industry. Now, moving on to the next fertilizer industry, which is phosphorus industry. So what is phosphorus industry and where do we get phosphorus from? What are the different types of phosphorus based fertilizers? All these we will discuss today. So phosphorus is a chemical element that has a symbol P and atomic number 15. As phosphorus was the 13th element to be discovered and can be used in explosives, poisons, and nerve agents, it is referred to as devil's element. It is essential for life. It is a component of DNA, RNA, ATP, and also the phospholipids that form all cell membranes. So it is one integral part of our living body itself. DNA में होता है, RNA में होता है, हमारा जो एनर्जी मॉलिक्यूल है, जो हमारा एटीपी है, उसमें भी एडिनोसिन ट्राइफॉस्फेट, तो उसमें भी फॉस्फोरस है. Then Henning Brand discovered phosphorus during his experiment on urine in 1669. Robert Boyle was the first to use phosphorus to ignite sulfur-tipped wooden splints, forerunners of our modern matches in 1680. Due to its high reactivity, phosphorus is never found as a free element on Earth. Phosphorus as a mineral is present in its maximally oxidized state as organic phosphate rocks, as inorganic phosphate rocks from which it can be extracted out. Phosphorus, which is primarily extracted from calcium phosphate rocks, considered as an expensive mineral, but with the increasing demand of phosphorus products like phosphoric acid, synthetic fertilizer, and phosphate salts, the situation demands modification in extraction method as well as product manufacture. So there are two elemental forms of phosphorus, white and red. Both are highly igneous. Even at 30 35 degrees they spontaneously ignite. You don't even have to give any ignition source. Just if you keep white phosphorus in the open atmosphere and the atmosphere reaches to 30 35 degrees Celsius, it starts to ignite. So that is why phosphorus is never found as a free element, but it is in form of inorganic salts. Then molecular formula, we know the molecular weight, then appearance, order, irritating order, boiling point to 80.5, melting point is density 2.2 to 2.34. Solubility, it is insoluble in water, but it is soluble in carbon disulfide. White phosphorus is a highly reactive, waxy, white, yellow, transparent solid with acrid fumes. It emits a weak green glow, that is luminescence, in the presence of oxygen. White phosphorus ignites spontaneously in air. Phosphate rock. So phosphate rock is a natural mineral found as a geological deposit on a large scale in the form of sedimentary rocks containing various amounts of calcium phosphate. India alone is estimated to have about 140 million tons of rock phosphate deposit, most of which are, however, of low grade and with substantial impurities unsuitable for the production of phosphate industry. Phosphate fertilizer. Phosphate rock is used as a phosphatic fertilizer. After grinding, it is called phosphorite or mineral phosphate, or it is used as a primary source of phosphorus. Finely ground rock, about 60 to 100 mesh size phosphate, can be applied directly to the acidic soil. Okay, we have phosphorus phosphate buffers, right, to reduce the acidity. For neutral or alkaline soils, acid treated rock phosphate like superphosphate is used. This is one type of fertilizer which is acid treated. Powdered rock phosphate is free flowing and is easily amenable to handling and storage. Crops like rubber, tea, coffee, apples, and fruit plantations of oranges are suitable for direct application of rock phosphate. Then phosphate rock, some more points. Francolite, that is calcium carbonate fluorapatite of formula, this is the formula, is the most predominant mineral of phosphate. Four kinds of phosphate rocks are recognized: hard rock phosphate, soft rock phosphate, and you have land pebble phosphate and river pebble phosphate with the phosphorus content varying from 2 to 21%. It is very minimum, but these are the four kinds of phosphate rocks that are recognized. Then phosphate rock contains phosphorus in an apatite form, which is water insoluble. The citrate solubility can vary from 5 to 17% of the total phosphorus, depending on the chemical nature of the rock and the size to which it is ground. The efficiency of the ground rock phosphate can be increased by mixing with soluble phosphorus and fertilizers, mixing with elemental sulfur and sulfur producing compounds, and using phosphate solubilizing microorganism. This is how the efficiency of the ground rock phosphate can be increased. More than 90% of the rock phosphate is used for production of superphosphate and phosphoric acid. Less than 8% is used directly as soil fertilizer, and about 2% is used as animal and poultry feed. How do we purify phosphorus from the rock phosphate or the calcium phosphate? So calcium phosphate is obtained after removal of various impurities present in the rock phosphate. The upgrading of ore and removal of impurities is carried out by flotation of phosphate rock. Clays, that is kaolinite, then illite, then smesticites, and ataprugite. These are the clays. Then you have quartz and other silicates like feldspar. Then you have carbonates like calcite and dolomite. Secondary phosphates, you have phosphate bearing iron and aluminium. And you have iron oxides like geothite, hematite, and magnetite are the common impurities which are associated with the phosphate rock. Phosphate ore benefaction is done by many methods. So phosphate ore beneficiation, that means to purify calcium phosphate and to remove the other impurities. So the first method by which you can go for phosphate ore beneficiation is Froth flotation. This is the first technique, okay, for phosphate ore beneficiation. The first technique is Froth flotation. It is a widely used technique in the phosphate industry. Froth flotation is generally employed with siliceous ores when other less expensive or less complicated techniques fail to produce phosphate concentrate suitable for chemical processing. Prior to its conditioning for flotation, the flotation feed of phosphate rocks is delined to remove the lines present in it. Then in the flotation of phosphate ores, apatite particles are generally directly transferred to the froth fraction. That is direct flotation by using anionic collectors such as fatty acids. The anionic collectors selectively attach themselves to the phosphate particles, render them hydrophobic, and lift them to the surface by the froth and air bubbles that are formed. The mineral bearing froth may simply overflow the cells and paddles or may be skimmed off. So mineral is skimmed off. Quartz and other silicates are removed from the bottom of the flotation cell. A second stage of flotation may be required to remove silica from the phosphate-rich float by cationic collectors, usually amines. When silica is floated and the phosphate particles settle to the underflow. A selective flotation of carbonates from phosphate rock is rather difficult owing to the similarity in the physicochemical properties of carbonate and phosphate minerals. Several treatments have been proposed, including flotation, calcination, acid washing, magnetic separation, and heavy media separation for the removal of free carbonates from the phosphates. So this is the flotation picture of phosphate ore. So here you have the heavy particle that is a sand, you have a solvent, and here you have the froth, which is brought to the surface with the help of some anionic collectors or cationic collectors. Then you have, these are actually floating phosphate particle, and you are putting air so that the bubbles are formed easily and they move up to the surface. So this is a representation. Then moving to the next one, yellow phosphorus. So far this is about white phosphorus. Now yellow phosphorus is given here. And manufacturing of yellow phosphorus, what you have to do is put the phosphate rock into a grinder, put them into a sinter, then a screen, because once it is sintered and it is screened, you will get the mesh size of whatever you desire. Put them into a hopper, and here it is in the furnace where it is burnt. You get a molten slag from here. Okay, you remove it, and that can be discarded. But you have to take the other particles from the top, apart from the slag, the molten state, you put them into a cooler, and this will give you CO, carbon monoxide. And from the cooler, the rock remains are sent to the electrostatic precipitator. So based on the charges, you get your yellow phosphorus, and the fines are sent to the waste. So this is process description for yellow phosphorus. So rock phosphate is crushed and as fine powder so that complete transformation to phosphorus pentoxide and finally element phosphorus possible. The powdered rock phosphate is mixed with sand and coke powder in the required proportion and charged into electric furnace having electrodes at bottom. The base of the furnace is heated with carbon blocks as the temperature increases due to electrical heating. Reaction of rock phosphate with sand starts at about 1150 degrees Celsius, resulting to calcium silicate and phosphor pentoxide. Then, further increasing the temperature to 1500 degrees Celsius, carbon particles react with phosphorus pentoxide, thereby phosphorus and carbon monoxide formed, which is collected from the top outlet. So this is sent to the next part, that is the cooling. Residual calcium silicate settles down at the bottom in the form of slag, which is taken out time to time from the outlet provided at the bottom of the furnace. Product gases, which is a mixture of phosphorus and carbon monoxide, is cooled in a water cooler, thereby phosphorus solidifies and carbon monoxide gas is separated. Purification of phosphorus is carried out by melting it and treating it with chromic acid. Then the carbon and silicon impurities are removed due to oxidation. Pure phosphorus, which is pale yellow color, is washed with water before it is casted into sticks. Then recovery, how do you recover the phosphorus product? The fumes emerging from the furnace are first freed from any other mineral or other fine reagents which may have been carried up at less than 300 degrees Celsius so that the phosphorus is not condensed out. The remaining gases consist of phosphorus, CO, and silica fluoride and are sent to the bottom of tower in which water is sprayed from two different heights. Care should be taken that the temperature should not drop below 60 degrees Celsius. The phosphorus condenses out before but does not solidify, and it is collected underwater, which reacts with silica fluoride and converts into metasilicic and fluorosilicic acids. The fluorinated components are subsequently recovered from the solution. Carbon monoxide, which is completely freed from phosphorus and fluorine compounds, is then cooled, dried, and subsequently used as a fuel. The slags consisting of calcium silica oxide, which is produced in the furnace and subsequently discharged from outlet provided at the base of the furnace, are the good additives for cement. So this, because it contains silica and it has this calcareous properties also, it can be used as an additive for cement, airport runway construction, and anti-skid conglomerates. Then the liquid phosphorus, after decoloration with the activated carbon, is filtered and solidified to yellow phosphorus. This yellow phosphorus is stored under water because it is highly ignitable. Then red phosphorus, another color is red phosphorus. So white or yellow phosphorus is both the same. Okay, there is nothing as pure white. So white or yellow phosphorus is almost the same. Now moving to the second type, which is red phosphorus. So this is the manufacturing of red phosphorus. We will see the two different methods. First is batch process. Yellow phosphorus obtained from earlier process is taken into iron pot provided with safety outlet and thermometer jackets. So for this, the precursor is yellow phosphorus. So yellow phosphorus हमने पहले वाले process में बनाया. अब ये जो है ये इसका raw material बन जाएगा for red phosphorus. Conversion of yellow phosphorus to red phosphorus is exothermic reaction and strict maintenance of temperature in the range of 240 to 250 degrees Celsius in required, as conversion do not take place below 240 degrees Celsius, and above 250 degrees Celsius, accident chances are more. After complete conversion, product is washed with sodium hydroxide solution, as yellow phosphorus is soluble, but red phosphorus is not soluble in NaOH. Now, continuous process, how do you do? In the process, liquid white phosphorus is maintained at a boiling point for 5 to 6 hours to achieve 30 to 50% conversion. The product is taken into a screw conveyor in which unreacted phosphorus vaporizes, which is recrystallized and recycled. The red phosphorus is of high purity and therefore doesn't require further purification. Applications of phosphorus, if you see, red phosphorus is used in fireworks, smoke bombs, and pesticides. Black phosphorus, no significant commercial uses due to least reactivity. White phosphorus and zinc phosphate are mainly used as poison for rats, especially in the farming. And if you have any problem at home, rodent problem, then we use that in rat poison. Then it is used in making incendiary bombs, tracer bullets, and for producing smoke screen. Used in fertilizer, which provides phosphate as required for all life and is often a limiting nutrient for crops. Used in the manufacture of other compounds. Okay. And organophosphorus compounds are used in the detergents, pesticides, and nerve agents and matches. Phosphorus is one of the most essential mineral in the body and is ranked second to calcium. However, the deficiency of phosphorus is relatively rare. Or about 80% of all phosphorus is present in the human body in the form of calcium phosphate in the teeth and the bones. So we have deposits of calcium phosphate in teeth and bones. It also participates in several vital functions of the body, such as energy metabolism, synthesis of DNA, and absorption and utilization of calcium. Phosphorus plays an important role in facilitating the optimal digestion. Then it helps in normal functioning of kidneys and ensures proper discharge of waste. Adequate levels in body is essential to maintain normal brain functions. So this was about phosphorus. Now we will move to the next associated compounds of phosphorus, from which we can use fertilizer. We can manufacture fertilizers and all. So I'll show you that one. Okay, so if we talk about the phosphorus industries, what are the different products? We have first is the elemental phosphorus, which is used directly in making bombs, explosives, crackers, and everything. Then phosphoric acid is used, superphosphate and triple superphosphate, they are all used in fertilizer industry. So we will talk about them now. So first is phosphoric acid. Phosphoric acid, also known as orthophosphoric acid or phosphoric 5 acid, is a mineral acid or an inorganic acid. Orthophosphoric acid molecules can combine with themselves to form a variety of compounds which are also referred to as phosphoric acids. Amongst the mineral acids, phosphoric acid stands in special status as it is used for specialty application including anti-corrosive and food industry. Out of the number of processes available, only the latest are discussed below, which includes applications of electric furnace, blast furnace, and process including oxidation and hydration of phosphorus, or the wet process using which uses sulfuric acid and rock phosphate. This wet process of production is very important process, which is commercially applied to all industries, which is of great industrial importance. So phosphoric acid, this is the formula: molecular weight 97.99, appearance white solid or colorless viscous liquid, about 42 degrees Celsius. Boiling point 158 degrees Celsius. Melting point for anhydrous it is 42.35, and for hemihydrous it is 29.32. Density is 1.885, and solubility it is soluble in water. Manufacturing methods: the first one using phosphate rock and blast furnace. So the modern methods, these are the modern methods employed. The first one is using phosphate rock and blast furnace. Second is using electric furnace. Third is using oxidation and hydration of phosphorus. Fourth one, wet process or from sulfuric acid and phosphate rock. So there are four different processes. First is using blast furnace. Second is using electric furnace. Third is by oxidation and hydration of phosphorus, elemental phosphorus. Okay, and fourth is by the wet process, in which sulfuric acid and phosphate rock are involved. So first is blast furnace. Blast furnace process was widely used in the first 3 decades of 20th century. Resulting phosphoric acid can be used in manufacture of insecticides, pesticides, detergents, but not for fertilizers. Raw materials: what do you need for the blast furnace process? You need 1000 kg of you need at least 2290 kg of phosphate rock, you need sand, you need coke, you need briquette binder, and you need air. And the reactions are given here. This is a manufacturing PFD in which all the raw materials like the phosphate rock, binder, coke, everything is put here, and it is pressed under a pressure of 5000 psi. Then it is subjected to the blast furnace where sand is also added. From the blast furnace, you have a dust collector here, and from the dust collector, what happens, you are going to send the phosphorus vapor to a steam boiler. From there it is condensed or hydrated, and it is collected here in the form of phosphoric acid by precipitation. Okay, So description is given here, you can read through it. Then we have engineering aspects, how the blast furnace should be designed. Blast furnace is made of high temperature resistant refractory brick, and blast furnace have accessories of hot blast stove for supply of compressed preheating air having temperature 1000 to 1100 degrees Celsius. Then you have briquettes press for preparation of briquettes of phosphate rock and coke, dust collector. Then you have two outlets for removal of slag, and you have a ferrophosphorus are provided at the bottom of the furnace. These are the components of the blast furnace. Application of this process, if you see, used for the preparation of hydrogen halides. It is used as a rust converter by direct application to rusted iron, steel tools or surfaces. Then food grade phosphoric acid is used to acidify foods and beverages such as various colas. Then used in dentistry and orthodontics as an etching solution to clean and roughen the surfaces of teeth where dental appliances or fillings will be placed. As an ingredient in over-the-counter anti-nausea medication that can contain high levels of sugar, used in many teeth whiteners to eliminate plaque, and used as a external standard for NMR and HPLC, as a chemical oxidizing agent for activated carbon production, and as an electrolyte in phosphoric acid fuel cells, and is used with distilled water. So these are the different applications. Then we have other applications also, used as an electrolyte in copper, then flux by hobbyists, like those people who are involved in soldering process. Then you can read through all the applications. There are several applications, you can read through this. So that was about phosphoric acid industry. And now we will see if superphosphates and triple superphosphate. Okay, so I'll share the screen for superphosphate. So these are the NPTEL lecture handouts, and there is one handout for phosphoric acid also. Now we just saw one method of phosphoric acid production, which is by blast furnace. Now there are three more methods, right? That is electric furnace, and you have oxidation and nitrolysis, and you have the wet process. So all the methods are discussed in this handout. So this is the blast furnace operation which we have seen. Then using rock phosphate and electric furnace also we produce phosphoric acid, and it has a PFD also. So you have an electric furnace instead of a blast furnace, you have an electric furnace here. Then advantages of electric arc furnace over other methods when compared to blast. What is advantage? The advantage of the electric furnace process lies in its ability to use as low grade phosphate rock, use a very low grade phosphate rock provided the major impurity is silica. Also, iron and aluminium oxide are not objectionable as in the wet process. Siliceous rocks contain 24% phosphorus as phosphorus pentoxide, and this is acceptable. The byproduct carbon monoxide is used as a fuel for calcination. Then moving to the third way of producing phosphoric acid is oxidation and hydration. So the reactions are given here. First is you are going to oxidize and then you add water. So this is the process flow diagram. You have phosphorus, you have air, you have steam, all put in the combustion chamber. And since you're adding air here the oxidation happens. The vapors are collected in this hydrator where water is added. So oxidation happens, hydration happens. Then go for a separator, then a cyclone separator, and then you capture them on a glass wool. Then wet process or from sulfuric acid and phosphate rock. So there are two processes like dihydrate and hemihydrates, okay, for producing wet using this wet phosphorus. So if you see, this is a PFD. So here, what are you going to administer inside? First sulfuric acid, then you put the phosphate rock, then you are going to add the recycled weak phosphoric acid from the end stream of this particular process, put them into a tank reactor. Okay, and what you do is when you are putting all the processes here, first it is a pre-treatment sort of thing, and then we are giving water, air, hot water at different stages, and you get the this one with the help of suction you get the phosphoric acid. So kinetics and thermodynamic aspects are given here for wet process. So grinding, then handling, amount of sulfuric acid, filtration of gypsum, purification, everything is given here. These are the steps involved in the process of formation of phosphoric acid, then how the sludge is disposed. Okay, so this was about the phosphoric acid. I'll upload this in your e-content. Then superphosphate is also here. So this is superphosphate. Superphosphate, also referred as single superphosphate, is the first chemically manufactured commercial fertilizer. And you can read through the introduction. So how do you manufacture? So we have the basic raw materials like calcium phosphate, sulfuric acid, water, electricity, and sources of raw material. You get a phosphate rock can be obtained and purified as described, we have already seen, and sulfuric acid can be obtained by contact process also we have seen. So these are the sources of raw material. Reactions are given here. How is the manufacturing happening? So first is the preparation of phosphate rock. Then first you go with the preparation of the phosphate rock, then mixing with acid, then curing and drying of original slurry by completion of the reaction, then excavation, milling, and bagging of the finished product, followed by granulation. So these are the steps in the process of manufacture of superphosphate. And superphosphate is manufactured by two different processes. One is batch process and continuous process. Batch process is Den process. Advantages is given here. Then continuous Den process is also given here. Okay, so you can read through the different processes for the manufacture of superphosphate. And now talking about the application, yes, of course, it was the first commercial fertilizer. The cost is also given here. Properties are given here. So as we see the uses, it is a principal carrier of phosphate. The form of phosphorus usable by the plants and is one of the world's most important fertilizer. It is low cost source of phosphorus in a wide range of pasture and cropping situations, then generally mixed with sulfate of ammonia and muriate of potash, but can be blended with other fertilizers. So this is about the superphosphate. Now we will talk about the triple superphosphate. So this is triple superphosphate, or this is a more concentrated fertilizer. वहां पे एक ही single superphosphate था, यहाँ पे triple है, 3 गुना concentration ज्यादा है इसमें. Advantages and disadvantages of this triple superphosphate is given here. Manufacturing of triple superphosphate involves the following steps. First is reaction, denning or den process step. हमने वहां पे भी देखा था, right? Batch, den and continuous den. So denning and den process step. Then storage and curing, and then you have granulation. तो एक एक step के बारे में उन्होंने detail में समझाया है. and followed by the raw material profile. You need phosphate rock, you need phosphoric acid, power, steam, labor, fuel, and then PFT is also given, followed by the process description. So why do we need to do granulation? What is the advantage? So you get the product at lower cost, generally then generate denser and stronger granules. So this is the reason why we go for granulation. And then what is X-done granulation? What are the advantages of this? Then uses of triple superphosphate. Triple superphosphate can be used in wastewater treatment to reduce lead levels, and it is a low-cost source of phosphorus. Then triple superphosphate is the main substitute for single superphosphate in cropping blends. It is used mainly in blends with DAP and MAP, diammonium phosphate and monoammonium phosphate. Okay, these are another fertilizers used. Source of phosphorus in situations where no nitrogen is required. Example: good fallow after clover dominant pasture. Then in horticulture blends where the phosphorus content needs boosting. So these are the applications of triple superphosphate. So almost we have covered the phosphorus industry. Now we have to discuss about the potassium industry. So if you can see at the screen, this is the syllabus. Phosphorus industries, we have seen the manufacture of phosphorus. We have discussed about phosphoric acid. We have discussed about superphosphate and triple superphosphate. So potassium industries, we will try to do it in the next lecture when we meet at 11:30. Okay, potassium chloride and potassium sulfate. So next lecture we will not have ASP. Instead, we will continue with potassium industry for fertilizer. Okay, so, and I'll see if I have any videos to share with you regarding phosphorus industry. So one video is available with me right away. It is about phosphate mining. How is phosphate mined? So we'll watch this video now, and then we will meet at 11:30 after the break. So I'll share the screen with you. Very basic video.
Of all the many elements drawn from nature, there is one you may not know much about: phosphorus. And while phosphorus isn't a word you hear very often, it's something plants, animals, and people need every day. Look at it this way. What do all these things have in common? Phosphorus. Phosphorus moves energy around the plant and makes photosynthesis possible. And what's the most important role of phosphorus? Feeding the world. Phosphorus works with other nutrients to grow healthy plants. These nutrients are found naturally in the soil, but are often not plentiful enough. And as farmers well know, a lack of phosphorus can be bad news. Phosphorus is the backbone of DNA, the genetic blueprint contained in every living cell. And it plays a vital role in the way living matter provides energy in cells. So when phosphate is lacking in soil, food crops simply can't grow as they should. That's when farmers turn to fertilizers, made from one of our nation's largest natural resources. These fertilizers increase the yield and quality of our nation's and the world's crops. In fact, fertilizers have increased our food supply by 50%. But where does phosphate fertilizer come from? The largest phosphate deposits in North America lie in the Bone Valley region of Central Florida. In fact, Florida's phosphate mining accounts for about 2/3 of the phosphate used in the United States, as well as about 15% of the phosphate used around the world. But significant phosphate deposits can also be found in Georgia, Idaho, North Carolina, Montana, Tennessee, Wyoming, South Carolina, and Utah. So how did these phosphate deposits get there? That's another story, a very old one. Scientists believe that these large phosphate deposits formed from the skeletons and decomposition from sea creatures living in the seas during the Miocene period more than 20 million years ago. At that time, large portions of the United States were covered by the ocean. But as the seas retreated, this prehistoric muck transformed over time to become phosphate rock. So, in effect, much of the food that we eat today comes to our dinner tables courtesy of animals that lived millions of years ago. Thanks, guys! Of course, these prehistoric sea creatures didn't exactly make it easy for us to make use of their ancient gift. From mine to manufacturing to farm, and ultimately your dinner table, the process of creating usable phosphate fertilizer is complex. It begins at the mine, where getting phosphate rock out of the ground comes in a very big way. Take a look at this amazing machine. It weighs 7 million pounds and can carve out over 75,000 tons of material a day. But before the job can begin, workers first have to get it into position. This gigantic machine is equipped with 2 giant mechanical feet that allow it to move. Once it's in place, it's time to begin. The enormous bucket does the heavy lifting. It's big enough to hold a car, weighs 110,000 pounds, and is secured by 10 4-inch thick steel chains. With a touch of the controls, this bucket can dig up over 140,000 pounds of a mixture called matrix, which consists of sand, clay, and phosphate. Then, workers behind joystick controllers hydroblast it in a sort of high-tech video game that comes to life. This creates a milkshake-like consistency of materials that can be pumped to a processing plant. At the plant, the matrix is separated through another high-tech process, and the phosphate rock is transported from here to a fertilizer manufacturing complex. The sand and clay are pumped back to the mine site for use in an ongoing land reclamation process. In fact, once the mining is finished, this land is carefully restored and reclaimed back into beautiful and high-quality ecosystems. Reclaimed lands may be used for commercial or agricultural uses, or even for development. Land reclamation displays the magic of science and Mother Nature as plants, birds, and other wildlife re-establish a thriving presence. Meanwhile, back at the fertilizer plant, phosphate rock is ground and mixed with water and pumped to an area where it reacts with sulfuric acid to form phosphoric acid, the basis for all phosphate fertilizers. Next, the phosphoric acid is combined with anhydrous ammonia to produce the fertilizer. The fertilizer then makes its way to distributors serving farms across the United States and the world, where the essential element of phosphorus helps each little plant grow. Energy within the plant cell is created, and crops thrive because of phosphorus. It's an amazing story that begins with sea creatures millions of years old and takes us from the mine to the farm and then to your dinner table. Working in unison with other nutrients, this incredible element is crucial to feeding the world's population of over 7 billion people. Phosphorus, a word you don't hear very often, but an essential nutrient to feeding the world.
Okay, so that was about the phosphorus mining, and we have seen the wet process also, where they are mixing sulfuric acid to form phosphoric acid, and then they are reacting it with ammonia to form fertilizers. So these are the different processes in the fertilizer industry using phosphorus as the base. Okay, so let's take a break, and we will meet again at 11:30, and we will continue about the potassium industry. So you can exit the meeting. Thank you.
Thank you, ma'am.
Okay, welcome.
Thank you, ma'am.